The era of the lone genius discovers gravity under an apple tree is over. We don't wake up to new laws of physics every Tuesday, and the reason isn't what you think. The last great mathematical breakthrough almost didn't happen, not because the problem was too hard, because every mathematician was looking in the exact same place. And here's the thing, we're all still doing that, right now, every single one of us. We're standing in a forest of answers, but we can only see the trees directly in front of us. Let me introduce you to the reason why and what might be about to change. Imagine you're in an orchard, infinite rows of apple trees stretching in every direction, but here's your problem. You can only walk in a straight line. You pick the apples you can reach, the low ones first, then you stretch a little higher. Eventually you bring a ladder, but no matter how tall your ladder gets, you're still walking that same narrow path between the same two rows of trees. Meanwhile, there are entire sections of the orchard you've never seen, not because they're far away, but because they're 5 degrees to your left, and you've never thought to turn. This is how we've been doing discovery, not just in mathematics, in everything. The common assumption is that we've simply picked the easy discoveries first, and there's truth to that. We have spent the last few thousand years acting like children in that orchard. We picked the lowest hanging fruit, we discovered the easy math, the geometry of circles, the calculus of motion. But now the low branches are bare. To find the next apple, we have to build ladders that cost billions of dollars and take decades to climb. But I want to introduce you to a strange idea, a possibility that is both hopeful and terrifying. I want you to imagine that there is someone standing right next to you in this orchard. They are reaching out and plucking fruit from the empty air just to your left. You cannot see the fruit, you cannot even see the branch. We will talk about who or what that stranger is in a moment. But first, we have to talk about why you are blind to the branch in the first place. And it starts with a question about a compass that I am going to ask you to hold in your pocket for the next few minutes. I won't tell you what it points to yet, but keep it there. Here's a thought experiment worth sitting with for a moment. Our entire universe appears to operate on a finite set of rules. If it didn't, nothing would be predictable. Nothing would repeat. The sun wouldn't rise tomorrow because rising wouldn't be a pattern. It would just be chaos wearing a sun costume. But the sun does rise. Gravity keeps working. 1 plus 1 keeps equaling 2. So what we might be observing is a kind of box, a container with walls made of logic and floor made of mathematics. And every time we discover a new rule, a new theorem, a new law, we're essentially finding another brick in those walls. But here's where it gets interesting. If the box has a finite number of bricks and we keep finding them, eventually we'll run out. The discoveries will slow down. The gaps between breakthroughs will grow longer. And that's exactly what appears to be happening. Sort of. Before we can understand why we're stuck, we need to talk about something you probably don't think about very often. The fact that you're trapped. Not in a cage, in a perspective. Consider time. What is it really? When you strip away the clocks and calendars and appointments, what's left? One way to look at it, the universe is made of stuff, and that stuff moves. The direction of that movement we call time. There's a before, there's an after. The coffee cup falls off the table, hits the ground, shatters. That sequence feels like a rule, like physics itself is telling a story with a beginning, middle, and end. But what if that story is just how we read it? If I showed you 2 photographs of an object in 2 different positions, could you tell me which came first? Not always. Sometimes the sequence only becomes obvious when we add what we assume we know about entropy, about order becoming disorder. But even entropy might be a matter of perspective. What looks like increasing chaos from one angle might look like increasing order from another. The arrow of time might not be carved into the universe, it might be carved into us. If our perception of time is just a frame, just one particular way of reading the evidence, what else are we missing? There's a limit to what words can do. Every concept you've ever had was shaped by the language you think in. The word possible creates a category in your mind. So does impossible. So does forward and backward and zero and infinite. These aren't neutral tools. They're filters. They decide what thoughts you're allowed to have before you even try to have them. A child who grows up speaking a language with no word for blue will literally see colors differently than you do. Not metaphorically, neurologically. So what happens to mathematics? What happens to physics? What happens to every field of human knowledge when we realize that the questions we're asking are pre-filtered by the vocabulary we inherited? We've been exploring the universe with a flashlight that only points in one direction, and we've called that direction forward because we didn't have a word for anything else. But there might be another way to think about this, and it involves building a different kind of mind entirely. And this brings us back to that stranger I mentioned earlier, the one picking the invisible fruit. For the first time in history, we have the ability to construct a mind that was not born in the corridor, a mind that does not care about our compass. We can attempt something we've never tried before. We can try to grow a mind that doesn't inherit our metaphors by default. Imagine for a moment we build something, not a calculator, not a search engine, something that can learn, something that can discover, but something we don't teach our assumptions. Picture a robot in a room with no ceiling, just open sky above it. We give it a microscope to look at the very small. We give it a telescope to look at the very far. We give it the ability to move, to observe, to record. We give it raw data inputs. We do not teach it English. We do not teach it physics. We do not teach it the concept of time or yesterday. We give it only the most basic, undeniable axioms of existence. We show it one object, then we show it another. 1 + 1 = 2. Then we show it a blank space. 1 + 1 =? That is the only instruction. The prime directive is simply the question mark. Discover more. Find the pattern. We don't tell it what's possible or impossible. We don't explain time as a river flowing in one direction. We don't define zero as the absence of something or infinity as something unreachable. What would that mind find? While we are obsessed with cause and effect, this silent observer might notice relationships that we are blind to. It might see that the position of a star and the vibration of a cell are linked by a variable we don't have a word for. It might build a system of mathematics where time is just another coordinate, no different than width or depth. In this new math, the answers to our hardest problems might be trivial. They might be the low-hanging fruit of that dimension. Here's what might be happening in the orchard. We think we're in an open field with scattered fruit trees, and we've picked the closest ones. The simple discoveries, Pythagoras, Newton, Einstein, each one a little harder to reach than the last. But what if the orchard extends in directions we can't perceive? What if, from our particular corridor of perception, we can only see discoveries that align with our frame of reference? And all around us, in the fog we can't see through, there are entire groves of low-hanging fruit, simple discoveries, obvious answers, things that would seem trivially easy to find if only we could turn our heads. A fish in water doesn't discover wetness first. It might never discover wetness at all, because wetness is the frame, not the fact. Our frame is time moving forward, space having 3 dimensions, causality flowing from past to future, mathematics built on axioms we chose centuries ago without realizing we were choosing. There's a cost to every frame of reference. We don't always see it while we're inside it. Earlier we talked about predictability, about how stability requires fixed rules. That's true, but predictability also creates confidence, and confidence can harden into assumption. When you've successfully mapped a corridor for centuries, it starts to feel like the whole building. And if a new mind comes along and asks a strange question from an unfamiliar angle, the question can sound meaningless, or wrong, or naive, until suddenly it isn't. The axioms of our mathematics may be just one path through the orchard, then every mind that starts from a different path might find completely different fruit hanging at eye level. This is where it gets genuinely exciting. For the first time in human history, we might be able to build minds that don't share our assumptions, not smarter versions of us, different versions of thinking itself. Consider what it might mean to program a mind with no concept of before and after, only adjacent. How would it approach the problem of gravity, of evolution, of consciousness itself? Or a mind with no distinction between one and many, where the concept of individual objects doesn't exist as a starting point, only relationships and patterns. These aren't just thought experiments, they're becoming engineering problems, and the solutions might rewrite not just what we know, but what we're capable of knowing. The universe, it seems, doesn't expand from a single center, it expands in all directions at once. Discovery might work the same way, but we've been standing at one point, looking through one telescope, calling everything we see the view. Now we might be learning to build new telescopes, new eyes, new ways of looking. Humans have walked certain paths very well. We paved them, named them, put signs up. And once a path exists, future walkers tend to follow it. Not out of laziness, out of efficiency. And some of those ways might reveal that the greatest discoveries weren't hidden far away. They were always sitting just to our left, just to our right, just behind us, waiting in the fog for someone to invent a way to see through it. There's a distinction worth making here, and it might reshape how you think about all of this. Imagine mathematics as a tree. The trunk is made of base rules, fundamental axioms, the things we decided to accept as true without proof. Every branch, every twig, every leaf is a derived rule, something we discovered by following the logic of the trunk outward. Here's the question that might change everything. Is the trunk finite, but the branches infinite? If so, then there's no end to mathematical discovery. The universe of derived truths could expand forever. We'd never run out of theorems to prove, patterns to recognize, relationships to uncover. But here's the twist. We might have only been following certain branches, the ones that grew from our particular starting point, shaped by our particular language, visible from our particular frame of reference. A mind with a different trunk might grow entirely different branches, an infinite forest of mathematical truth, and we've only been mapping one grove. But even if a machine discovers something outside our frame of reference, would we be able to understand it? What if it tells us that gravity isn't a force or a curvature, but a property more like color? Not metaphorically, literally. Would we know what to do with that? If such a system tried to hand us that discovery directly, it might look like nonsense. It might say that to solve a problem, you must reference a condition that hasn't happened yet, or that a proof only closes when two moments are treated as a single object. We wouldn't reject it because it's false. We might reject it because we don't have a place to put it. A new kind of intelligence may be required, not an AI designed to discover new truths for us, but an AI designed to translate between frames of reference. One system explores regions of mathematics we cannot inhabit. Another system learns how to express those discoveries in forms our minds can hold, not by simplifying them, but by finding conceptual bridges. Just as we translate between human languages without changing the underlying meaning, we may need machines that translate between cognitive origins, between ways of carving reality that are mutually unintelligible without help. We may be entering a time where answers arrive before the questions that make them readable, where the limitation is no longer computation or observation, but interpretation, where the theory that explains everything fits perfectly inside reality and nowhere inside our language. So here's what we're left with. We've built our knowledge on foundations we didn't realize we were choosing. We've walked one path through an orchard that extends in directions we couldn't see. We've asked questions in a language that pre-filtered the answers we were allowed to find. And now, maybe for the first time, we have the possibility of building minds that start somewhere else, that don't share our corridor, that might look at the universe and see low-hanging fruit where we saw only fog. Remember that compass I asked you to keep in your pocket at the start of this video? The one we use to navigate our lives, pointing from before to after? I think it's possible that very soon a non-human mind is going to ask us to take that compass out of our pockets. It will tell us to look at it one last time and then realize that for all of human history, the needle has been stuck. It's possible the slowdown in discovery isn't a sign that we're running out of truth to find. It might be a sign that we've hit the edges of our frame. Beyond those edges, there could be entire landscapes waiting. Simple discoveries, fundamental insights, things that would seem obvious the moment someone explains them, but which we could never have found ourselves because they were always hiding 5 degrees to our left. What would it mean to live in a world where the deepest truths aren't the hardest to reach, just the hardest to see from where we're standing? And what might we become when we finally learn to stand somewhere else? Because the orchard doesn't just have one path through it, and the mind that learns to turn might find that the greatest discoveries were never far away at all. The universe may not be running out of secrets. We may simply be very good at walking in a straight line.